But almost at the same time as relativity started gaining universal acceptance, a radically different picture of the universe was emerging.
The way out, if you don't want to accept the block universe idea, is quantum mechanics. Now, quantum mechanics is the other great theory of 20th century physics, and that states that the future isn't predetermined and preordained.
Quantum mechanics was born out of a series of experiments whose results even today have no satisfactory explanation. Relativity works at the large scale, where it provides exact predictions of what will happen next. But when physicists started looking down to the atomic and subatomic level, the familiar laws failed. At this level, there were no certainties, only probabilities. How can the future of the entire universe be already out there if the future of a single particle is so utterly unpredictable?
Before we look to check to see what the atom is doing, not only is there a gap in our knowledge, not only do we not know what it's doing, the atom itself hasn't decided what to do. If it had an infinite number of choices to make, it will be doing all those choices at once. And it's only when we look to see what's happening that we force it to make a choice. Quantum mechanics, the future is not determined. And so quantum mechanics, in a sense, rescues us and rescues free will.
In a sense, you don't have the future laid out in quantum mechanics. So quantum mechanics is basically different in the way we look at it. You do have, at least when the measurement takes place, you do have this indeterminacy about the future, and it's, in a certain sense, I suppose, the incompatibility with a picture of special relativity is a necessary feature of this, the fact that there is this indeterminacy and having, in a sense, incompatibility with relativity. The notion of free will is incompatible with relativity, as we understand relativity. It's not incompatible with quantum mechanics. In a sense, quantum mechanics, as we understand it, allows for this indeterminacy in the future, whereas with relativity, there is a basic incompatibility. So I think that the way we understand these two theories at the moment, there is a difference in relation to how one views whatever free will is. Relativity is sort of inconsistent with it. Quantum mechanics is not. So we have these two great theories, both of which are extremely accurate, tell us something about the way the world operates, something very insightful and profound and accurate about the way the world operates, but they're incompatible with each other. So there's something missing, and there's no doubt about that. How important that is for such things as, for example, how we feel the passage of time, well, I think it is important.
The tragedy of modern physics is that it explains so much of the objective universe, but at the cost of what we subjectively feel, about our conscious free will and our perception that time does flow.
I very much think there's a flow to time. If you consider what music would be like if there wasn't a flow to time, you couldn't have music if you didn't have a memory, or if you didn't have an expectation generated from that memory. You'd have an isolated note in the now. Music unfolds in time in such a way that we have a memory of what we've heard, and this memory conditions what we expect. And this, of course, is something that everyone's familiar with. Because if you hear, you have a very strong expectation that the next note will be. Music is a distillation or a side effect of that mental faculty we employ to perceive time and things changing in time.
The question of the passage of time, I think, is something that physicists have rather set aside. and taken the view that in a sense it's not really physics. I mean, it's a subjective issue, and subjective questions are not part of science. Now, when you start talking about phenomena like one's individual perception of the passage of time, then that is a subjective thing. And that's almost a taboo subject for science because it's subjective. The physical world is out there, and certainly the view according to relativity is it's sort of out there, and there's no flow of time, it's just there. Whereas our feelings, we have this feeling of a passage of time, and so it's something intimately connected with our perceptions.
We have this subjective feeling that time goes by, but physicists would argue that that is just an illusion.
Yes, I think there is the view that scientists or physicists particularly would tend to take, that somehow the flow of time or our feeling of the flow of time is something, an illusion, that it's not really real in some sense. But it's certainly true of how we perceive time. And okay, what kind of an illusion it is, I mean, it's got something to do with our perceptions.
Illusion or not, our perceptions emerge somewhere between the cosmic scale of relativity, where the flow of time is frozen, and the quantum scale, where flow descends into uncertainty. Our world is on a scale governed by a mixture of chance and necessity.
I mean, this is my own view, which I'm going out on a limb here, that other people don't necessarily share with me, this particular view. But the view I have is that there is a kind of large-scale quantum activity taking place in the brain. Quantum mechanics doesn't necessarily say that quantum effects take place only very tiny. It's not just individual particles. They can involve large areas. And so the argument is that such a thing is taking place over large areas of the brain, and that our conscious perceptions, our conscious actions, our conscious willing has to do with that process. You're then bringing in an area of physics which is quite different from either our large-scale picture of space and time or our small-scale picture of quantum mechanics. It's a new picture which comes in just at that level. And I think you need a new picture to explain something like consciousness, which has a different relationship to time.
If quantum events are at the root of consciousness, then the same principle of uncertainty which governs the subatomic world might explain our ability to make apparently random choices. Opening up the future to the possibility of change would provide the first step of restoring to physics the flow of time it currently denies.
I don't think time flows. I feel that time flows, but I think the only way we can get a better understanding of this is to have a better understanding of how consciousness works. I think human consciousness probably has the secret as to how and why we think of time as going by.
I don't think we have the tools, not just the tools, we don't have the physical picture to be able to accommodate these things yet. It doesn't mean that I don't think we will ever accommodate these things within some kind of physical picture. It's just that we're not very close to it yet. Now, it may be that when we understand more about how quantum mechanics and relativity fit together, we'll see a passage of time out there also, not just within ourselves.